Okay, so the last concept in this unit is finding the derivative of inverse trig functions. So before we do that, we are going to look at review, I suppose is a better word, what we covered in trig with inverse trig functions. So inverse sine of x equals y, that is an inverse function. So that means that x is equal to the sine of y. So remember, we take trig functions of angles. So y is an angle. And the result of our trig function is a trig ratio. So x is a ratio. So we take an inverse trig function on a ratio, and it takes me back to the angle that gives me that. Now, arc sine is another notation that we used. Arc sine of x equals y. And remember, our domain, our range for sine is going to be the domain of our inverse sine. So sine is always a number between -1 and 1. Sine of an angle is always a number between -1 and 1. So inverse sine we can only take on values between -1 and 1. And then the range, we had to restrict the domain of our original function to make the inverse sine function actually be a function. So inverse sine only exists in quadrants 1 and 4. If we remember that, in quadrant 1, it is a positive rotation up to pi over 2. And in quadrant 4, it is a negative rotation to negative pi over 2. So the only angle inverse sine is ever going to give you is an angle between negative pi over 2 and positive pi over 2. Inverse cosine, same thing. We have, that means that the cosine of y is x. And once again, cosine gets us values between -1 and 1. So for inverse cosine, it gets us an angle. We take the cosine of an angle, and x again is the ratio, and our ratio is going to fall between -1 and 1. Inverse cosine only exists in quadrants 1 and 2. So the angle that I'm going to get out of my inverse trig function is going to be between 0 and pi. So 0 to pi over 2 is going to get me quadrant 1, and then to pi is going to get me quadrant 2. So I have a restricted range on my original, or on my, I had a restricted domain on my original function, and I'm going to have a restricted range on my inverse function. And then tangent, oops, I also forgot this. Arc cosine of x equals y is the other notation that we can sometimes use. So inverse tangent of x means that the tangent of y equals x. or this could be arctangent of x equals y. That's the other way I can write inverse tangent is arctangent. Again, we take tangent values on ratios, and what comes out. Oh, I wrote this backwards. No, I didn't. I wrote it right. So my x values for tangent, the ratios can be any number. But inverse tangent, when I'm thinking of the graph of tangent, if I look at my graph of tangent from negative pi over 2 to pi over 2, tangent graph is going to look like that. So my ratios are from negative infinity to positive infinity, but inverse tangent only exists in quadrants 1 and 4. Quadrant 4 is to the left of the y-axis. Quadrant 1, this is quadrant 4, 1. And in quadrant 1, it is a positive rotation, but at pi over 2, we have an asymptote, so it will only equal pi over 2, but not, or less than pi over 2, but not equal to. And in the negative rotation, again, we can't equal the vertical asymptote, only up to it. So our angles are going to fall between, our angles are going to fall between negative pi over 2 and pi over 2 inclusive. These are the three that you really need to know. You can look in your textbook for the other three inverse trig functions. You will not be expected to do those on the in-class test. If they showed up on the take-home test, you would know where to look in the book to find them. Evaluating inverse trig functions. So we have here arc cosine of a ratio equals an angle. The way that we looked at these in pre-calc was pretend that's a circle. There we go. Inverse cosine exists only in those two. And I have a positive root 3 over 2. That is the long side. So that means that y is going to be, that rotation is pi over 6. If I asked for the inverse sine of negative root 3 over 2, if I said that was going to equal y, again, inverse sine exists only in quadrants 1 and 4. And in quadrant 4, it's a negative rotation. So sine is the y value, and that is the long side of my triangle. So that is going to be a negative pi over 3 rotation. Hopefully this is coming back to you a little bit from trig last year in pre-calc. So inverse tangent, again, inverse tangent exists only in quadrants 1 and 4 again. But tangent is a little harder because we remember that what this means here is that the tangent of y is equal to the square root of 3, which is basically the square root of 3 over 1. And that came from root 3 over 2 that came from root 3 over 2 over 1/2. Those are the special right triangles. So this is going to give me the sine of y over the cosine of y. So I have a positive sine that is root 3 over 2 and a cosine of 1/2. So that is going to be in that location. So that is, that means that y equals pi over 3. And then we did solving of equation. So if I have arctangent of 2x minus 3 equals pi over 4, I can convert my equation. So if arctangent of something equals the angle, that means the something is equal to the tangent of that angle. And tangent of pi over 4 is root 2 over 2 over root 2 over 2. So that means 2x minus 3 is 1. Tangent of pi over 4 is 1. So 2x equals 4. So x equals 2 is my solution to that inverse trig function equation. And then we did composition of functions. So inverse trig functions are just angles. So this is asking me to find the cosine of an angle. And that angle, so this says cosine of theta. But what I know about that theta, I know that theta is equal to the arctangent of x, or in other words, x is equal to the tangent of theta. So I'm going to draw this with a quadrant 1 orientation because I don't know if x is positive or negative. If I do it with quadrant 1 orientation, it'll work itself out if I have a negative. So tangent is opposite over adjacent. And so I know that I want the cosine of this angle, so I need to find the hypotenuse. Well, using Pythagorean theorem, my hypotenuse squared is going to equal 1 squared plus x squared. So let's call this c. C squared is going to equal 1 squared plus x squared. So c will equal the square root of 1 plus x squared. So my cosine of this angle is going to be, cosine is adjacent over hypotenuse. So this will be 1 over the square root of 1 plus x squared, or I could write it as the square root of x squared plus 1. But I cannot take the square root of both of the pieces because it is inside and or there's addition or subtraction inside the square root. So derivative of inverse sine. So what we're going to do to figure out the derivative of the inverse sine, I'm going to use the inverse function. I'm going to convert from inverse sine to sine. So that means x equals sine of y. So now if I take the derivative of both sides, 1 equals derivative of sine of y is cosine of y times y prime. So now what I know is if I solve for y prime, I'm going to get 1 over the cosine of y equals y prime. The problem is inverse sine is in terms of x. So I need the derivative in terms of x, not in terms of y. So that idea that I just did here, where I represent the angle, I know that x equals the sine of y. I'll write this over here again. So y is an angle. I'm going to draw, again, with quadrant 1 orientation, my angle y. And if x is the sine, sine is opposite over hypotenuse. I need my ratio. So now I know if this is c, I know that 1 squared equals x squared plus c squared. So 1 squared minus x squared is going to equal c squared. So c is going to equal the square root of 1 minus x squared. Now that should be plus or minus, but again, I'm drawing it with quadrant 1 orientation. So it will, if the sign will work out if it's elsewhere, because with the derivative, I'll end up with the negative in there. So this side here is the square root of 1 minus x squared. So now what is the cosine of angle y? So y prime is going to equal 1 over the cosine of y. So here, the cosine of y is adjacent over hypotenuse. So the cosine is the square root of 1 minus x squared over 1. I probably don't need to write that over 1. So my derivative is 1 minus x squared underneath that square root in the denominator. So y prime is equal to 1 over the square root of 1 minus x squared. So what that means is the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. I needed the derivative in terms of x, the derivative of inverse sine of x in terms of x. So let me move this down a little because I am the worst at estimating space. So if the derivative of inverse sine of x is 1 over the square root of the quantity 1 minus x squared, what is the derivative of inverse sine of, inside parentheses, x squared minus 1? So this is going to be a chain rule. So the derivative of inverse sine of something is 1 over the square root of 1 minus the something squared. And then I need to multiply by the square root of the inner function. So the square root, or not square root, sorry, the derivative of the inner function, the derivative of x squared minus 1 is 2x. So my derivative is going to be 2x over the square root of 1 minus the quantity x squared minus 1 squared. Because this goes here, and then its derivative goes there. Did I write it? No, I wrote another one. All right, so let's try this one. The derivative of the sine, inverse sine of e to the x squared. So see if you can do that one. Go ahead and pause the video. So the derivative of inverse sine is 1 over the square root of 1 minus whatever I'm taking the sine or inverse sine of. So that is going to be e to the x squared squared. And then like we did when we did natural log, we're going to end up multiplying by the derivative of the inner function. And then that's going to end up being in the numerator. So I'm just going to go ahead and write, instead of writing the chain rule, multiplied by the chain rule, derivative of the inner function, and then rewriting the fraction, I'm just going to put the derivative in the numerator. So the derivative of e to the x squared is e to the x squared times the derivative of the inner function, which is derivative of x squared is 2x. Let me give you just a couple others. The derivative of arctangent of x, of u, because we've got chain rule, is the same as the derivative of inverse tangent of u is going to be u prime over 1 plus u squared. The derivative of inverse cosine of u, or the derivative of arc cosine of u, is u prime over the square root of 1 minus u squared, which looks like sine of u, derivative of inverse sine. For cosine, the difference between derivative of sine and the derivative of cosine is a negative. So the derivative of inverse cosine is negative u prime over the square root of 1 minus u squared. And then I will write this in the same notation. Derivative of arc sine of u is going to be u prime over the square root of 1 minus u squared. There are the other inverse trig functions, again, which you do not need to have memorized those, but you can find them in the book on page 371.